I am Temitope Adeniji, and you're welcome to Organotope Chem Clinic, where chemistry becomes crystal clear. You're about to understand what 90% students find confusing. Ever wondered why gases behave the way they do? Let's dive into the science. Let's crush today's topic in a way your brain will love. The first thing we need to understand about the properties of gas is that these gas molecules occupies the entire volume of the container where they are found, and the collision with the wall of the container is perfectly elastic. And at the same time, gas molecules are highly compressible. That is, we can compress the molecules of gas. So the next thing we need to understand, in the study of gas law, there are four main variables we need to consider. The first one is the pressure exerted by the gas on the wall of their container. We have the volume occupied by the gas, the number of mole of the gas, as well as the temperature of the system where the gas exists. So let's go into the first law, which is the Boyle's law. Boyle's law states that volume of a given mass of gas is inversely proportional to the applied pressure, provided temperature is kept constant. Mathematically, we have V is inversely proportional to pressure at constant temperature, and the amount of gas molecule remains constant as well for Boyle's law. What does this inverse proportionality imply? Inverse proportionality implies that as volume increases, pressure decreases. Here we have a volume drop, that is a decrease in volume, so we expect the pressure to increase. When volume drops, pressure does what? Pressure increases. So in an instance whereby we have an increase in the volume of gas, so we expect the pressure to drop. An increase in volume of gas results into a decrease in pressure. That's what inverse proportionality implies. So from this expression, we have V equals K over P, where K is the constant, proportionality constant. So we can say PV equals K. For series of experiments, we have P1 V1 equals P2 V2 for Boyle's law. Also, we can see that as pressure increases, volume decreases. As pressure decreases, volume increases. So we have this illustration. Okay, this is decrease in pressure resulting to an increase in volume, which implies that when pressure is doubled, volume is halved. When we have P1 to be P, V1 to be V, you have P1 as P, V1 as V. Therefore, P2, when it is doubled, V2 would be halved. That's what we can deduce from the Boyle's law. We have the piston. When I push the piston downward, then the volume decreases, and the collision of the gas molecule with the wall of the container becomes what? Increases, thereby increasing the pressure exerted on the piston. So pressure increases while volume decreases. When the piston is pulled upward, the volume tends to increase while the pressure reduces. So increase in volume results to a decrease in pressure for Boyle's law. Here is the mathematical expression for the Boyle's law. Graphically, we can express the Boyle's law. We have the graphical representation for Boyle's law. The first one, V against P, which shows what? Inverse what? Proportionality. That is, volume is inversely proportional to pressure. Also, we have the representation V against inverse of pressure, which shows a direct relationship, straight line. And the next one is PV against P, which is a constant proportionality. So the graphical representation for Boyle's law, we have this V against P, which is a curve, V against inverse of pressure, which is a straight line passing through the origin, PV against P, which is a constant proportionality. So please kindly note that when pressure is increased by a factor of 2, volume will decrease by a factor of 2. When pressure is exerted on the wall of this balloon, the volume tends to decrease. We have the gas compressing right here, while in an instance whereby the pressure is reduced, the volume tends to increase for a balloon. The next gas law we need to consider is the Charles law. Charles law shows the relationship between volume and temperature, and the law states that volume of a given mass of gas is directly proportional to the temperature, provided pressure remains constant. Mathematically, we have V is directly proportional to temperature, provided pressure and number of mole remains constant. So we can illustrate the Charles law with this chart here. I have a piston right here, and this. It can be observed that there is a decrease in volume right here as a result of the decrease in temperature. When the temperature increases, considering the heat source right here, 1, 2, 3, when the temperature increases, the volume of the gas molecule tends to increase. So the piston rises up. Here, as a result of the temperature drop, there is a decrease in volume. So when temperature decreases, volume also decreases for Charles law. When we have an increase in temperature, volume increases for Charles law. That is what direct proportionality implies. V is direct proportional to T. When we remove the proportionality sign, I will introduce a constant. I have Kt. Make K the subject of the equation. I have V over T equals K. For series of experiments, we have V1 over T1 equals V2 over T2. That is for Charles law. From this expression, we can deduce that when volume increases, temperature also what? Increases. So temperature is a factor for an increase in volume. When volume is doubled, when temperature is doubled, volume is doubled. Increase in volume results to an increase in temperature, or vice versa. Increase in temperature results to an increase in volume. If I have T1 decreasing, T2 decrease in temperature will result to a decrease in volume for Charles law. Graphically, we can represent Charles law this way. We have a straight line. This time around, the straight line is not passing through the origin. I have V against temperature, volume against temperature. Here in degree, in Kelvin, temperature in Kelvin, I have at this point, it is 273 Kelvin. At this point, boiling temperature, it is 373. So we have the extrapolation of this line graph, and we have it at point 0 here. Volume right here is in cm cube and temperature is in Kelvin. If we are to express this in degrees Celsius, I'm going to have this as 0. This will be 100 degrees Celsius, and this tends to be minus 273 degrees Celsius. We are going to consider that further when we are talking about the temperature conversion between degrees Celsius and Kelvin. It can also be observed that when a balloon is taken into an oven and the temperature of that environment is increased, the volume of the balloon tends to increase as well, to a point whereby it eventually bursts. Okay, so an increase in temperature results to an increase in volume. So the gas particle that we have in this container, when temperature drops, the volume also drops. The piston goes downward. When the temperature increases, the volume tends to increase. The piston moves upward. That is for Charles' law. The next gas law is Avogadro's hypothesis. Avogadro's hypothesis states that equal volume of any ideal gas at the same temperature and pressure contain the same number of molecules. The hypothesis was later recognized as Avogadro's law, which states that volume of a gas is directly proportional to the number of mole or molecule, provided temperature and pressure is kept constant. Mathematically, we have V is proportional to N, which implies that as volume increases, the number of molecules also increases. We have in the chart, from this chart, we can see that an increase in volume results to an increase in the number of molecules. A decrease in volume also results to a decrease in the number of molecules. Here we have proportionality sign. We introduce a constant. We have Kn. Make K the subject of formula. We have V over N equals K. For series of experiments, V1 over N1 equals V2 over N2 for the Avogadro's law or hypothesis. And from this chart, we can see that as volume drops, the number of molecules drops. As the volume increased by a factor of 2, the number of moles also increased by a factor of 2. The particles here is 5. 1, 2, 3, 4, 5, while the particles here has been doubled by 2. 2 times 5, that's 10. So the number of molecules tends to increase as the volume increases for Avogadro's law. The number of particles contained in 1 mole of a specific gas is given as Na. That is the Avogadro's number, which has the numerical value 6.023 times 10 raised to power 23 per mole or molecule. And also, under the Avogadro's hypothesis, the molar volume of any gas is given as Vm, and it has the constant 22.4 dm cube or 22.4 liter. The Avogadro's number is 6.023 times 10 to the power 23, while the molar volume is 22.4 dm cube or liter. The next gas law is the Gay-Lussac law, which shows the relationship between pressure and temperature. The law states that the pressure of a given mass of gas is directly proportional to the absolute temperature in Kelvin, provided the volume is kept constant. From the charts, we can deduce that as pressure increases, temperature also increases. When there is a pressure drop, the temperature also decreases. So an increase in temperature will result to corresponding increase in pressure, while a drop or decrease in temperature will result into a corresponding decrease in the pressure, because both variables are directly proportional to each other. Mathematically, we have P equals Kt. When we make K the subject of the equation, it becomes P over T equals K. For series of experiments, we have P1 over T1 equals P2 over T2 for the Gay-Lussac's law. That is, as pressure increases, temperature also increases, vice versa, because they are directly related. We can have a review of the gas law. The Boyle's law shows that the volume is inversely proportional to pressure, and as volume increases, pressure decreases, vice versa. So mathematically, we have P1 V1 equals P2 V2 for Boyle's law, while the Charles law shows that volume is directly proportional to temperature. Mathematically, we can see that V1 over T1 equals V2 over T2 for the Charles law. The Avogadro's law or hypothesis shows that the volume of a given gas is directly proportional to the number of molecules, and mathematically we can have V1 over N1 equals V2 over N2 for Avogadro's law. While the Gay-Lussac's law states that the pressure is directly proportional to temperature. As pressure increases, temperature also increases, vice versa. Mathematically, we have P1 over T1 equals P2 over T2. To watch more of my videos, kindly click the subscribe button and share with your friends right now. You can also follow and like my Facebook page. Thanks for watching.